So this should be our very last one, very last example on these things. They even wear me out. Okay, so to start, let's see here. Our first term is going to be this part to the fifth power. So I'm on my fifth row already. So make sure you go down to that fifth row on the Pascal's triangle. So we're going to have negative 2x to the fifth power, and then plus, and there's going to be our coefficient, which is a 5 this time. And then it's going to be a negative 2x to the fourth power and a 3 right here to the first power. Plus, we're going to have a 10. It's our second coefficient. And then it's going to be a negative 2x to the third power and a 3 to the second power. So notice these are adding up to 5 each time. They're kind of trading off with each other. As this one goes down, 4, 3, the other one's going up. And plus, we're going to have another 10 right here. It's going to be negative 2x to the second power, and my 3 is going to go up to the third power. And then there's going to be a 5. And even writing my paper sideways, I wasn't able to squeeze it all in. So there's going to be a 5 right here. I don't know why I have it in parentheses. And it'll be a negative 2x to the first power. Guess I got to squeeze in a second piece of paper here. To the first power, and then my 3 is going to bump up to the fourth power. Okay. And my last term will be a 3 to the fifth power. Okay. So you got to make sure, go back and check that all your powers add up to 5 this time. They should all add up to 5 this time. All right, let's work this thing out. So this is negative 2x times negative 2x 5 times. So because you're doing it an odd number of times, your answer to it is going to be negative. So for this part right here, we're going to get negative, and then 2 to the fifth power, that's equal to 32. And then x to the fifth. All right. Now, let's count our negatives here. All right, since we have 4 negatives, negative 2, 4 times, this will continue to be plus sign. Now we're going to do 5 times 2 to the fourth, because I'm ignoring the negative now. 2 to the fourth, and I gotta grab that calculator again. So 5 times 2 to the fourth times 3 to the first power. That's equal to 240. And that'll be x to the fourth. And then for this term, we've got 3 negatives. So I already know it's going to be a minus. These are just going to alternate now. We've wisened up to their schemes. 2 to the third, and, that's 2 to the eighth. 2 to the third is equal to 8. And then 3 to the second times 3 to the second's 9 times 10. So we get 720 there. 720, and then that'll be x to the third. That's how many x's we had left. And then for our next one, all right, we've got 2 negatives. So this is going to be a plus sign this time. We're going to have 10 times 2 to the second. That's equal to 4 times 3 to the third. 3 to the third is equal to 27. All right, 1080. 1080, and that'll be x to the second. And then I need to piece together my remaining parts here so I can see where I left off. A little puzzle action there. Cool. All right, for this piece, it's going to be minus because there's only one negative right here. All right, we got 5 times 2 and then times 3 to the fourth. All right, so 3 to the fourth is equal to 81 times 5 times 2. That's equal to 810. 810x. And then the last piece, you can't see it over there, that last piece was 3 to the 5th. And 3 to the 5th this is going to be a plus sign because there wasn't any negatives involved on that last piece. 3 to the 5th is 243. There you have it. All right, notice I got my step where I plug it into the formula. I want to see that. And then my last step where I work it all out. All right, and that is it for the binomial theorem. Woo!